Question 15 from Paper 2 of the 2024 Higher Physics examination from the SQA. A set of garden lights is powered by an array of solar cells. The set of garden lights consists of 10 LEDs connected in parallel, and each LED is connected in series with a resistor. The combined resistance of each LED and resistor is 220 ohms, and there's part of the circuit shown there. And for 3 marks we have to calculate the total resistance of this part of the circuit. Well, there's an easy way to do it, or you could do it the long way. I'll show you how we do it the quick way, just by using the formula. We know that if we've got 2 identical resistors in parallel, 1 upon RT is going to equal to 1 upon R plus 1 upon R equals 2 divided by R. Therefore, the total resistance must be a half of the original resistance, R divided by 2. That's what we've got 2 resistors in parallel. We can extend that to go to 5 resistors in parallel. So 1 upon RT is going to equal to 1 upon R1 plus 1 upon R all the way up to 1 upon R for the 5th one. We add it up, we get 5 divided by R. And therefore the total resistance, once we flip it, is going to give you R divided by 5. So the pattern is, if you've got N resistors, identical resistors in parallel, then the combined resistance is going to be the value of that resistance divided by N. Just as simple as that. So in our case, we've got 10 resistances, and we have a resistance of each one to be 220 ohms. Therefore, the combined resistance RT is quite easily found. It's the total resistance of one of them, 220 ohms. They're all the same value, so if we divide by how many is in the parallel part, 10, so divide by 10, and our answer is, for that part of the circuit, there's 22 ohms of resistance. Question 15 continued, part B. A solar cell is a p-n junction. When photons of light are incident in a p-n junction, a potential difference is produced. And for 1 mark, we're asked to state the name of that effect. The name of the effect is called the photovoltaic effect. So photovoltaic is what we have. We can break that word down. We can see we've got photo to do with light, and voltaic, we are producing a voltage. And for 3 marks in part 2, we're asked, using band theory, explain how a potential difference is produced when photons of light are incident on the junction, the p-n junction. Let's take a look at the simulation to see what's really happening, to get a clearer view. You can see the photon coming in, producing the electron-hole pair. There's another electron-hole pair produced, and the electrons, they tend to go towards the n-type of the material because they can't surmount that little hill there. And the holes, they tend to drift towards the p-type. So what you're getting is, you're getting these charge carriers produced, and the electrons are then drifting towards the n-type with a negative charge, and the holes drifting towards the p-type with a positive charge. So you're getting a separation of charges, and the separation of charges is going to produce a potential difference across the depletion layer. So to recap again, we have a photon of light coming in. It produces an electron-hole pair. The electron is promoted to the conduction band. The electron drifts down to the n-type, and the hole drifts up to the p-type. You get a separation of charge, and therefore you get a potential difference.